Today's lecture is about working with client-side code. It does have some server-side topics as well, but the biggest focus is on making a client-side code work. The plan for today's lecture is basically to develop an add-on. So we will develop an add-on that we are going to use in the Shoutbox app. So you will see how the process looks from like the very start, where you start developing an add-on, and then how you link it to your project. Now that we have our Shoutbox application with all the bells and whistles, we are missing room navigation. So currently, if the user wants to switch a room, they have to type the room's name in the URL address. And what we are going to do is that we are going to add a support for that. So we need an area in which recently visited rooms are shown, and we want to prevent the user from having to scroll the list. So all the rooms are there, and clicking a name of the room will just navigate to there. And we would like it to be reusable in other settings. So in this case, we are selecting a room name from a bunch of predefined names, but we maybe would like to be able to select, I don't know, a person from a number of persons or something. We would like to make it a Vaadin add-on. With this in mind, we have the following goals. The resulting code should produce basically a bunch of labels or buttons to select one from. So it would look something like a menu bar, but it would behave like a Vaadin select component. It should be possible to wrap the content into a number of lines by just specifying how many items we want per row. It should work with Vaadin data model, so we should just be able to provide a Vaadin container, and then any and all changes made to that container should be reflected in the widget or in the component itself. And let's call it flat select. As we are doing this for the purpose of the lecture, we are going to completely ignore efficiency, and this is supposed to be an example, so show you the ways of working and not the production code. What we should have is that on the server side we should derive from abstract select. Point is that we are completely going to ignore styling. So a few design decisions. We are decoupling client from server. So the server-side code, the Java code that is run on the application server, does not render. The client is not responsible for any component logic. And then we want some flexibility there, so we would like to be able to choose a property that holds a caption. So we do not have to pass, for example, strings. We can pass objects. Well, we want to have a maximum number of items per row as well. The last bullet point is also something that is very important to any Vaadin add-on. So there should be a meaningful default behavior. The component works out of the box without any fine-tuning. So we should just be able to pass a simple collection, as we can do with all selects in Vaadin, and it should work. So there should be some options to customize it, of course, but right out of the box, just when you start using the component, it should work. And I'll show you how to achieve that. So let's take a look at project structure. So this is the Maven command that builds a new Vaadin add-on project. It may look familiar. It basically, the only thing that has changed from creating an application is here. Here we replace Vaadin archetype application with Vaadin archetype widget. We specify Vaadin version as we would normally do, then we name the component and versions and so on and so on. Something will be generated. And what exactly will that be? First of all, it will create a root directory with the name of our project, and then there will be two subdirectories in it. One of them will be suffixed with add-on, and this will be the source code for our add-on. There will be a different project called demo, which is a sample app for our add-on. What is good is that this approach already sets you up for using your component. Let's take a look at the add-on files. First, in our package, we have a class called component name and then Java. So that's the server-side component. Then we have a widget set file, which is a resource that contains the definition of the client-side widget set. And then there is a file with styles. So more files. Now on the client side, there is way more files and way more classes than on the server side. All the client-side code is in a separate package, and it contains the definition of a client, RPC. It contains a connector, which is a utility for synchronizing a state of an object in a browser with an object in a server. In addition to client RPC, there is a server RPC, and then we have state. This is the information about the state of the component, so the snapshot of a position in which it is. So what data exactly it stores, and then of course the server side maintains this according to the business logic of the component, and then the client side will use this information to present the component to the user in a browser. Oh, and then there is a widget. So let's take a look at the shared state, which is the communication channel. By the way, everything that I say here about developing an add-on and all those shared states and RPCs, this is how the framework actually works. Shared state is something that is used from server to client, and as confusing as it may be, it's not the other way. To circumvent that, you can use server RPC, so you define an interface on the server side that the client can call. These are both properties common to client and server, and of course, as such, they depend on what is the purpose of your add-on. This gets serialized by the framework. What you can put there is basically everything except object. You can't use a generic object type. You have to use concrete objects, you have to use beans or primitive types, and then maps and arrays of the above. So that will work, with the exception that maps must be string indexed. And as I said, this is handled behind the scenes. It's optimized quite well. And this is done through the concept of dirty components, which I will talk about in a minute. As I said, you can put basically everything there in the shared state. The question is, can you put components? Can you put other components? For example, let's assume you're building a new kind of layout and you want to paint the components that you have just added. Turns out that you actually can't do it because the components exist only on the server side. Fortunately, we can use connectors. So instead of storing components in the shared state, you store connectors. That's it. The only rule is that the components must exist in the runtime hierarchy. So we either have to add the component somewhere or we have to set the parent of that component to something. Otherwise, we will get nulls passed to the browser and it will be a source of really hard to trace errors. And as it says here, it forces the server side to remember its components. So let's take a look at the workflow. So now we know that there is this shared state and what exactly happens. Let's say that the server-side code changes the state. That state gets serialized and of course deserialized on the other end automatically. Then the widget gets updated based on the state. The connector on the client side receives the event that the state has changed and then does something in response to that. And then we await user interaction. So the new component is painted and then we wait what the user will do. And the user will probably do something which will invoke a method call to the server. So we are making a request to the server, which causes the server side to change the state of the widget, which causes state deserialization and serialization and so on, which updates the widget based on the state, and that continues until we close the browser window actually. This is the kind of flow that happens in each component. A few notes about the shared state. It's a base class. You can make it either as a bean, a Java bean that has getters and setters, or you can have public fields, which you can then directly reference. The caveat is that you need to have a zero-argument constructor to your shared state. An extension of shared state is abstract component state, which is of course a base class for everything. So you shouldn't directly extend from shared state. Instead, if you ever need, you should extend from this one, because it stores a bunch of useful things for you. And of course, each component in the framework has its own subclass of that. You can use whatever is appropriate. So this is how our components state will look like. We need to store basically three things for the client side to render properly. We need to have an index of a current value, so which of the current values is selected. If it's -1, as in here, well then that means no value is currently selected. We need to pass available options, and then we need options per row. So how many elements per row of buttons we are going to accept, and if it's 0, then we're just going to accept all of them in one row. With this in mind, let's take a look at the server side, so the part that maintains the state changes and kind of controls the business logic of our component. Basically, the server-side component listens to the client-side calls. So whenever something happens in the widget, an RPC call is made to the server, and then we modify the shared state according to that. Now, the question is, how do we tell the framework that we need to do something on the client side? And here is where dirty components come into place. So there is a method called markAsDirty, which, well, marks the component as dirty and indicates that it should be repainted on the next response. There are a few key methods in there, so of course each server-side component should have setters and getters for the properties. So the state is, I would say, it's something internal to the component. Accessing the state should be done always through the API of the component itself. Then you should implement a method called getState that returns a flat select state. So our flat select will have the following setters and getters. So we need a selection index, we need caption property, so which property of the objects that we have passed to it we should use as a caption, and options per row, so how many options per row we want. And since we are using abstract select, then we already have the methods for setting the container data source. And when should we mark the component as dirty? So when do we need to update the client-side code? First, when we set the selection index, so when we select something. When we change the number of options per row, that also should trigger like repainting of the component, because it will look differently now. And of course, any container events, they should also result in repainting the component because, well, the available options have changed. What is important, I would say, in developing a component, whenever you get state, it actually marks the component as dirty. You can call getState with a Boolean parameter, and if that Boolean parameter happens to be false, then you're, well, getting a state without marking the component as dirty. So now that we have the server-side code, I can show you actually the server-side code. So this is as it was generated by Maven with some corrections, I would say. So there is flat select here. This is our component flat select, which extends abstract select. You shouldn't worry for now for the server-side RPC and a bunch of constructors that we have. So we have an option for setting options per row, which means we're getting a state, we're putting that information there. You can notice if we go up, there are no fields for storing these things here because they are all in the state. These methods are overridden from the abstract select. So when we set container data source, well, we want to update the options. And this method, so first we check if the container data source is specified and if it has more elements than 0. And if it does, then we're getting the item IDs and then we map captions based on those IDs. And then we collect them to list, which we convert to array because we use an array in the shared state and then we just put that to the state. Otherwise, we produce an empty array. Now, a few words about the client side. I said something about the connector. The connector is something common to both the client-side widget and the server-side component. And we have server connector, which is working on the client side. Then we have client connector, which works on the server side. Server connector is something that receives state changes from server-side components. And client connector is something that it enables to send state changes to client side. But this is some sort of magic that is done by the framework. So component connector is used by the client-side widgets. It enables to reference components in a shared state. So as I said, if you want to refer to a component in a shared state, you have to use connector. And there is one method in each component connector that we have. It's called onStateChanged, which, as you can guess, is invoked by the framework whenever we change the state. Our connector is extending from abstract component connector. And you can see the annotation here. This is the only reference to the server-side code in the client-side code. So this is how the framework knows that for this component, for flat select, it should use this as a connector. We have 3 methods implemented for us in the connector. Create widget, which does some GUID magic to instantiate the flat select widget And then get widget and get state, they like reduce typecasting, of course. And then again, there is some magic involved in the return types. And then there is our onStateChanged event. As it says here, whenever the state changes in the server side, this is called. Yes, exactly, that's what happens. And we get an event here that corresponds to the state changed. And you can see that we are using it exactly the same way as we would do it in the server-side code, because it's the same class. And this method called setOptions is something that it exists in our widget. We added it ourselves. The widget is the client-side, purely browser-specific object. Then in the connector, we actually connect the events about the state changed with the state of the client-side widget. And the widget itself, it extends a GUID widget. Framework offers you a possibility to integrate JavaScript components. You can write one widget from scratch if you want. In most cases, it would be pointless because GUID is huge. Like there is basically everything you ever need. We are still using GUID 2.7, which is unfortunately a Java 7 compiler. The widget itself, it just renders, so it doesn't really care about the state. Actually, I will show you the widget maybe. You can see that I'm extending a GUID vertical panel. Then I have an option button, which is a button that stores an index, so of position where it is. And here is our setOptions method. As I said at the beginning, this is not a production code. I have ignored efficiency and code styling and everything. I just scrambled stuff there. So what happens here is that we're constructing a horizontal panel. So we have a vertical panel. So our components in the widget are arranged top to bottom. So we're passed a set of options and we want to arrange them in rows. So as many options per row as it's allowed. And then if we reach the limit, then we add a new row. So to have them aligned nicely, we have a vertical panel to which we add horizontal panels. And then in those horizontal panels, we have the buttons themselves. And this is the logic for actually switching to the next row if we reach the limit or not. And here is an option button that we create. We pass an index to it, we pass a caption there. If it's currently selected, then we add a style name to it that it's selected. Otherwise, we remove the style name. And then we add a click handler, which will invoke callback object about the button clicked. Callback is something we have here. It's an interface for our particular widget that contains what to do when this button was clicked. And if we go to our connector, then you can see that we are making a callback here that will call an RPC. And RPC is what we are going to talk right now. So RPC stands for Remote Procedure Call. It's another of the three-letter acronyms that are widely and wildly used in IT. I don't know for what reason. RPC is supposed to be means for stateless communication. So you indicate that something has happened, like a button was clicked, I don't know, a cursor went somewhere. Something happened. You don't know the state of what is now, but you know that it happened then and at this position, for example. It works both ways. So the client calls the server by making a request, and then the server calls the client in response. What is good with our Maven generated code is that it creates working stubs. All the simple things are there. Basically, then the only things you do is that you provide your own implementations and leave everything else unchanged, which is very good. One slide about what happens when we want to call the server. So when the widget registered some sort of an event, we have an interface called flat-select server RPC, which extends from a server RPC. And these are the methods that the client can call. In our case, it's just one method. It's called selected, and it's the index of the selected option. That's it. Server side has the implementation of this method. So we need to register the RPC on the server side as well, so that we are able to track this call or to execute code in response to client calling this method. And the client side creates a proxy. So framework actually takes care of that the proxy will serialize that call to a request. And this is how it's done. This is the magic line. This is exactly this. So here we create a proxy, and here we call it. The reason why it's in the connector is that I just didn't want to pollute the widget code with RPCs and stuff, because now it allows me to reuse the widget somewhere else, maybe in a different connector, in a different component. I can show you how the receiving end of it looks. So, well, first of all, let's take a look at flat select server RPC. So this is the interface. There's absolutely nothing here. Here is our server-side code. So this is where we actually provide an implementation for our RPC. So this is what we are proxying on the client side. And here we are just forwarding this call to the method selected item at index. The other way around is that we have a flat select client RPC, which extends client RPC. And these are the methods that the server can call on the widget. We are not doing this in flat select because everything that is important goes through the shared state. But if we did, then we could, for example, have a method called setSelected, which basically highlights the selected button on the client side. And now it's the reverse. So the client side has the implementation and the server side creates a proxy. That's it. Now it's the demo time. You can get the add-on from GitHub if you want. It's also in the Vaadin directory for the purposes I will show you just in a minute. And I'll just run the demo and well, I already explained the code a bit. And the code is also mostly generated so that it showcases how you use the component. Well, here it's just a few things that I did. There is an array of options, and then whenever we change the value of the component, we also change the caption of it so that we know that actually it works. So that when you click the button on the client-side code, then it will store the value on the server-side code, and actually it will even broadcast value change events. Oh, it's still compiling, never mind. It will take forever on this machine to actually compile it. Well, you can, I mean, you're pretty skilled in imagination, I guess. You can imagine a browser window with flat select with buttons. It has 3 options per row and a bunch of, how many options are there? 1, 2, 3, 4, 5, 6, 7. So it will have 3 rows with buttons, you know. So if you remember, we started developing flat select because we wanted to have room navigation in our Shoutbox app. So now we can actually use it there. So now that we have our fancy component for room navigation, let's use it. So let's add a dependency to it in the project POM. And then let's just use it as any other component. So the rooms are quite dynamic. We don't have a fixed list of rooms. So whenever we enter a room, we just add the name to select or to the component or precisely to a container that contains those rooms. And then when we click the button, we should navigate to the room that corresponds to there. And now we should also use Cloud for widget set. I have spent like 4 hours yesterday at home trying to figure out why on earth it doesn't work. And then I just cloned the stuff here on my laptop and then it worked. You can see the add-on here, so it's added as a dependency, and you can see that the widget set mode compilation is CDN. So when you develop or when you first create your app, this says local, but you can switch it to CDN and then it will work. There are some advantages and disadvantages of having the cloud compiled widget set. The biggest advantage is that you save time because, well, it's done by somebody else's computer. And then you just use it. The drawback is that if that service suddenly stops working, then your application also stops working because there's no widget set to display. Where on earth did I put the flat select now? So there is a container for rooms. You can see it here. So we have flat select entitled rooms, and we're passing a container with rooms to it. Then we set some width and height, and then here is the crucial part. So whenever a value has changed, we get the navigator and we navigate to that room name. That's about it. Let's run it. This should hopefully work a bit faster. There we have it. So this is how our flat select looks like. And I can type stuff here type stuff. It will display it, and of course, since, as I said, rooms are dynamic, I have to first type in a new room name, so room. And then there we got a button that corresponds to it. I can type something here. And I can switch back to the main room. You can see that the URL has changed. So basically, that's how our add-on works. And that's how you use it in an application. Today, I quickly went through the client-side development, so connectors and shared state. These are the most important parts of developing your own add-on. And as I said previously, the whole framework works exactly this way. So it's just, it's nothing different than what the normal components do. Then there was the RPC. So how should we use RPC and how do we call the methods? How do we register them? Who owns the implementation of what? And so on. And then how to use custom add-ons. So as I said, when you generate the add-on or the widget archetype through Maven, then you already get an example of how you should use your custom add-on, because you get a demo project in which your add-on is already referenced. But you are not allowed to use cloud compilation there. You can do it only when your add-on is in a public repository. So it's either in Maven Central or in a Vaadin directory. And this is the only places where cloud compilation can actually fetch the code from and compile it for us.